Building consensus is not a new concept. Consensus has been around for as long as human beings have lived together. In its most basic form, it is just a way for diverse groups to make decisions without conflict. Consensus mechanism is one of the most important features of blockchain. For example, as a family, we all love to go for an outing once in a while, right? Now the decision on the destination is arrived at through discussion, taking everybody's opinion into account and then deciding on a single destination through consensus. Point to be noted is that the final destination may not be the favorite of everyone, but all have agreed to it. Similarly, if a group wants high quality decision with a strong following, they have to spend the time to create proposal or plan involving all group members. Similarly, a consensus mechanism is a fault tolerant mechanism that is used in blockchain based networks or applications to achieve the necessary agreement on a single data value or a single state of the network among distributed processes or multi-agent systems such as with cryptocurrencies. It replaces third-party trust with the mathematical proof that something definitive has happened, is traceable and therefore provable. In other words, this acts as a single source of truth. In any centralized system, like a database holding key information about birth and death data in a district, a central administrator has the authority to maintain and update the database. The task of making any updates like adding, deleting, updating name is performed by a central authority who remains the sole in charge of maintaining genuine records. But how it is done in a blockchain? In blockchain, the consensus is not achieved through discussion. Public blockchains that operate as a decentralized, self-regulating systems work on a global scale without any single authority. They involve contributions from hundreds of thousands of participants who work on verification and authentication of transactions occurring on the blockchain and on the block mining activities. In such a dynamically changing status of the blockchain, these publicly shared ledgers need an efficient, fair, real-time, functional, reliable, and secure mechanism to ensure that all transactions occurring on the network are genuine and all participants agree on the consensus on the status of the ledger, and the same is achieved through complex mathematical algorithms, and each of the nodes accept the outcome of these complex mathematical algorithms. The important question that arises before using blockchain is whether or not there will be multiple mutually untrusting stakeholders coordinating action on a single database. If the answer to the above question is yes, then distributed ledger technology like blockchain is a perfect solution. Using blockchain, user will be able to create a database environment where various stakeholders can append records without a central coordinator. If the database does not require coordination between a large number of stakeholders and can function with one sole writer or editor, then one should go with the centralized databases. The classical examples where centralized databases make more sense are tech giants like Google and Facebook. It is easier for them to track information in a centralized database rather than a decentralized one. Google's Gmail has a feature like smart spam filters that's possible only because Google can see through almost all emails of users. Having given the example of Google and Facebook for centralized databases, it is just a matter of time before they also embrace the decentralized bandwagon as the whole world is moving in that direction. The second most important issue to consider before using blockchain is trust among its users. If all users trust each other, then simply a distributed database can be used in which each user maintains a copy and free to edit and update the database as per their wish. Distributed ledgers are often considered as trustless systems where participants don't trust each other, which may not be completely correct, especially for a private blockchain, which we will be discussing in a later session. But for the public blockchain, the statement is correct to a great extent. Public blockchains are permissionless, where anyone can join and participants do not actually know each other and hence cannot also trust each other. So, if one of the participants appends new transaction data to blockchain, it should be accepted by everyone. In blockchains, and especially for public blockchains, this acceptance is achieved through complex mathematical algorithms, and way to gain acceptance is known as consensus mechanism. The diagram charts the transaction journey from initiation to being written onto the blockchain database. Let us see at what stage the consensus mechanism will be applied to a transaction. The transaction, once created and posted to the network, is signed with the signature of the transaction's initiator, which might indicate to spend the money or create a contract or pass some data parameters associated with the transaction. If the transaction is signed, then it is valid and has all the information for it to be executed. The transaction is then sent to a node that is connected to the network and knows how to validate the transaction based on the predefined criteria. Invalid transactions are discarded, whereas the valid transactions are propagated to few other nodes in the network. These nodes will further validate the transaction and then send it to few other nodes until the transaction reaches each node in the network. This flooding approach ensures that a valid transaction will reach every node in no time. The sender or the initiator do not need to trust the nodes they use to broadcast the transaction as long as they use more than one to ensure the transaction is propagated. The recipients need not trust the sender either, as the transaction is signed. Once the transaction is validated and added to a block, it is then propagated to the network. Once the whole network reaches a consensus and the other nodes in the network accept the new block, it is changed into the blockchain. Once recorded on the blockchain and confirmed by sufficient subsequent blocks, the transaction becomes permanent part of the public ledger. Let us discuss consensus with few examples. In this example, we look at the supply chain solution that IBM and Walmart working together on for food traceability and transparency. So why is there a need for food safety and transparency? Almost 1 in 10 people fall ill after eating contaminated food. 55.5 to 93.2 billion a year is a total cost incurred in food-borne illness. Since there is a dire need for food safety and transparency and the involvement of multiple players or stakeholders from farm to consumer, the use case is ripe for implementation of distributed ledger and other features of blockchain like consensus and smart contract. As the diagram illustrates, food supply chain nowadays is a global with number of stakeholders involved. As you can see in the diagram, the stakeholders ranges from producer, which is a farm, packaging house, transporter, border crossing, processing facility, retailer, and customer. Most of these stakeholders are not known to each other, though they are part of the same supply chain. To provide complete transparency to the end customer or consumer, the contribution from each stakeholder matters, and that too the right contribution. In such a situation, the distributed ledger technology like blockchain is required, as all of these stakeholders do not have complete trust in each other, and that trust is achieved through the consensus mechanism.